Okay, this is section 1.5, solving inequalities. So the first thing we're going to go over is just some addition properties and subtraction properties of inequalities. So I know this looks weird, but I want you to be able to tell what they're talking about over here. It says for any real numbers a, b, and c, so they're just some numbers, a is greater than b, then a plus c is still going to be greater than b plus c. So that just kind of makes sense. If I have 4 is greater than 3, okay? And then I say, all right, I'm going to add 1 to both sides. So I have 4 plus 1 is greater than 3 plus 1. Well, that's going to be true. If I add the same number to both sides, it's not changing that inequality at all. And same thing with this. If A is less than B, then when I add that same number to both sides, that answer is still, this answer is still going to be less than this answer. And then the same holds true for subtraction. If A is greater than B, then when I subtract a number from both sides, I'm still going to have that same inequality. An example would be if 8 is greater than 5, and then I subtract 3 from both sides, then my answer to that will still be true. 5 is greater than 2. All right, so that's what this addition and subtraction property of inequalities is stating. So let's review some vocabulary real quick. Sometimes students get confused on which one is which. Greater than is always pointing this way to the right. That's greater than. Another vocabulary that you might use for greater than is more than. Less than points to the left. Greater than or equal to has the line underneath it. Some more words that might be used for greater than or equal to would be is at least or is no less than. So if I have at least $5, that means I have $5 or more than that. If I have no less than $5, I have $5 or more than $5. Less than or equal to, the equal to sign is this little line underneath our inequality. More words or other words that can describe that is at most, is no more than. So if I have at most $5, I have $5 or less than that. If I have no more, if that item costs no more than $5, it's going to be either $5 or less than that. Okay, so that's just a quick review of some vocabulary you might see. So we're going to do a simple example. We're going to solve y minus 6 is less than 3, and we're going to graph our solution set on a number line. Some graphing reminders that you might forget. We're going to use an open circle for greater than and less than, and a closed circle for greater than or equal to and less than or equal to. All right, and I'm going to have some basic graphing rules that we're all going to follow. So first of all, y minus 6 is less than 3. We started off pretty simple. So I want to isolate my y, so anything with the same side as my y I'm going to get rid of. So I'm going to add 6 to both sides. And we can do that because of that addition and subtraction property of inequalities. So I have y is less than 9. Okay, so that is my solution set. When we're solving inequalities, we don't have just one answer. We have lots of different answers. So I'm going to graph this. On our number line, I want at least 5 numbers on your number line. And what I normally do is I usually take my answer that I got, 9, and then I usually make that my middle number, and then I fill in numbers to the right and to the left. So that's going to be 9, 10, 11 to the right, 8, 7. Okay. Now we're going to graph this. So when I graph this, I'm going to go to my answer, y is less than 9, and I'm going to circle 9. It's going to be an open circle because it does not include 9. It's all the numbers less than 9, not including the number 9. So if I want to graph all the numbers to the left or that's less than 9, I'm going to go this way. You're going to shade it in and put an arrow saying that it's all those numbers to the left of that. So all of these numbers that are shaded in should work when I plug it in. I'm going to check it. I'm not going to make you show your check on all your answers. But if I plug in 8 in place of this y, 8 minus 6 is less than 3, 2 is less than 3, that's a true statement. So I know that that's right. If I were to plug a number over here that's not shaded, like 10, 10 minus 6 is less than 3. Well, 10 minus 6 is 4, and that's not less than 3. So that's what our solution sets are telling us. We have more than just one answer. All right, so now let's look at some more properties. These are multiplication properties and division properties. So you might remember back in Algebra 1 that when you're solving inequalities, if you multiply or divide by a negative number, you had to switch that inequality. Well, that's what all of this is saying. Okay, so let me show you what they're talking about. It says if A is greater than B, so I'm going to choose two numbers. I'm going to say my A is 5, my B is 3. So 5 is greater than 3. Then if I multiply those same numbers by the same number, I'm not going to change that inequality. 10 is greater than 6, and that's still true. But look what happens when I multiply by a negative. So I still have 5 is greater than 3. Let's say I multiply these numbers by negative 2. Whoops. So 3 times negative 2. So now I have negative 10 is greater than negative 6. Well, that's not true. Negative 10 is smaller than negative 6. So this shows that any time you multiply or divide, the same thing happens when you divide, by a negative number, you have to switch around that inequality. All right? So that's one rule you need to remember. When multiplying or dividing by a negative, you switch around your inequality sign. So let's look at an example. One way that they might ask you to write your answers today is in set builder notation. So the solution set of an inequality can be expressed by using set builder notation, and I'm going to show you what that looks like and how you would actually read it. Let's do this example first. I'm supposed to graph the solution set on a number line and then write the answer in set builder notation. So I have negative 4.2x is less than or equal to negative 29.4. So I'm solving for x. Again, this is a pretty basic problem. I need to get x by itself, so that means I'm going to divide by a negative 4.2 on both sides. When I divide by a negative 4.2, this is that special case where I need to switch around my inequality sign because I divided by a negative. So I'm going to switch this around. Now it's greater than or equal to negative 29.4 divided by 4.2. Negative 29.4 divided by 4.2 is going to be a positive 7. Okay, so first of all, let's go ahead and graph that on a number line. So I'm going to have my number line. I'm going to put the number 7 in the middle. 8, 9, 6, 5. Okay, I'm going to go to 7, circle it. This is a closed circle this time because it's also equal to. And I want all the numbers greater than 7. X is greater than or equal to 7. So this time I'm going to go to the right. All right, so that means any number that's on the shaded side, if I plug it into my original equation, it's going to give me a true inequality. So now let's write our answer in set builder notation. When I write my answer in set builder notation, it looks like this. It's going to be bracket, and then you're going to use your variable that was in your problem, x, and then you're going to draw this straight vertical line. And I'm going to read it out loud after I write it. And then x is greater than or equal to 7. So this is how it's read. This is read the set of all numbers x such that x is greater than or equal to 7. So I'm going to read it again. The set of numbers such that x is greater than 7. Okay? The set of all numbers x such that x is greater than 7. That is set builder notation. All right, let's do another example. Example 3. Graph the solution set and write the answer in set builder notation. So I'm going to write it down here. Negative 4c is less than 5c plus 58 divided by 6. So the first thing we're going to do, I see that fraction. I see this fraction right here, and usually we don't like dealing with fractions, so we're going to get rid of that. If they're dividing by 6, I'm going to multiply. I'm going to change colors here. I'm going to multiply both sides by 6 so I can get rid of that. So 6 times negative 4c, that's negative 24c. Now these 6's will cancel. So now I don't have to worry about that. Is less than 5c plus 58. Now we're just going to solve for c. I'm going to bring my c's over to the left-hand side, so negative 5c. So I'm going to subtract 5c from both sides. Add and keep your sign, so negative 29c is less than, those cancel, 58. Divide by a negative. So I'm dividing by a negative 29, which means I need to switch my inequality. And 58 divided by 9, 58 divided by 9 is, 58 divided by 29 is 2. And it's negative 2 because my signs are different. All right, so now we're going to graph that. So I have negative 2. Now you have to be careful when you're filling in your negatives. If negative 2 is here, negative 1 is on the right and 0. Then negative 3, negative 4. So make sure you get your numbers correct when you're writing your numbers in on your number line. I'm going to go to negative 2, circle it. It's an open circle because it's not also equal to. And I want all the numbers greater than negative 2, so it's to the right. When I write my answer in set builder notation, I'm going to write the set of all numbers, C, such that C is greater than negative 2. Okay, it's kind of hard. That's a greater than sign. Okay, example 4. Okay, graph the solution set number line and write the answer in set builder notation. So I'm going to rewrite it down here. We know by looking we're going to have to get rid of our parentheses by using the distributive property. So that's the first thing I'm going to do. Negative 6 times negative 4v. Negative times negative is a positive 24v. Negative 6 times 3 minus 18 is less than or equal to, now I'm going to use the distributive property again, 2 times 10v, 20v, 2 times 3 plus 6. So now let's get all of our v's on the left-hand side. So I'm going to subtract 20v. So 24v minus 20v is going to give me 4v minus 18 is less than or equal to 6. Add 18 to both sides. 4v is less than or equal to 24. Divide by 4. V is less than or equal to 6. And I didn't have to worry about changing my inequalities because I never multiplied or divided by a negative number. So let's graph this on a number line. 6 goes in the middle. Okay, I'm going to go to 6 and circle it. This is going to be a closed circle because it's also equal to. I want v is less than 6, so all the numbers less than 6, so all the numbers to the left. And then I'm going to write my answer in set builder notations. So my answer is going to be the set of all numbers v such that v is less than or equal to 6. Okay, last example. All right, Rose's cell phone plan cost her $50 per month plus 25 cents for each minute she goes beyond her free minutes. How many minutes can she go beyond her free minutes and still pay less than a total of $70? So first, let's use this information right here to come up with an equation. We know that no matter what, she's going to pay $50. Okay, so $50 plus we know she's going to pay 25 cents for every minute that she goes over, but we don't know how many minutes that is, so we're going to call that M. So 25 cents times the number of minutes she goes over. So I have 50 plus 25 cents for every minute. And we know we don't want this amount to go over $70. So she wants to pay less than $70. So less than $70. So that's our equation. We have 50, not equation, our inequality is less than 70. I'm going to subtract 50 from both sides. So 0.25 m is less than 20. Divide by 0.25. So m is less than 20 divided by 0.25 is 80. So let's see if we answered our questions. How many minutes can she go beyond her free minutes? M stands for minutes, so she needs to stay less than 80 minutes past her free minutes to stay below $70. Okay, that is your assignment, or that's your lesson. Your assignment is on your notes page.